Assalamualaikum warahmatullahi wabarakatuh. Welcome again to our YouTube channel. For today, we'll be doing discussion on our lab section that been doing on last week. Before we continue to our discussion, I would like to introduce myself. My name is Muhammad SYAZANI bin Shah, and my other group members, Muhammad Asyraf bin Razak and AZZAM MURLINDA. So we will starting our discussion on our lab section. So for today, we are discussing about how we want to do the insulation test to ensure the insulator property meets the International Electrotechnical Commission (IEC) standard. So to achieve our result, we will following 4 steps to make insulation test. So firstly, I will discussion about how to identify the correct apparatus for hypo test. So on the section 1, to make hypo test, we must have a test transformer which rating 100 kV and 10 kVA, and measuring capacitor, grounding switch, top electrode, connecting rod, connecting cup, flow pedestal, and lastly the secondary part for CB, impulse. So for the next section 2 is about how to assemble AC generation and measurement system. So in this section, we will be discussing on how we draw the connection circuit between the FC to the transformer tap point. So as you can see at the picture that we have been drawn by our group members, before we connect to the FC, we will supply it with the TNB supply, and then the connection will be goes to the transformer checkpoint. So as you can see on the bottom at the FC is connect to the 3 point at the transformer, and the grounding is tapping at the ground. And so on the transformer point, if you see at the transformer plate on the video that been shown by our lecturer Jikri, on the plate that has a connection guiding that we have to be see. So from the connection, so to make the transformer works in the range of 0 to 100 kV, so we must have connection to we must do the connection to PX and IPU. You will see the connection on the bottom of the drawing of transformer that connect to PX and IPU. So with the connection, we can have a range 0 to 100 kV. So after that, we will connect to the capacitor, which is our capacitor divider. So as you can see, the connection is is there. So Asyraf, we will go to the consideration of the transformer winding property. So the transformer to be function generating high voltage and isolating transformer. So in order to generate high voltage level, the configuration coming out to the secondary coil, so we must know the number of turn in the secondary coil must be adjusted relative to the primary coil. So as you can know, transformer has 2 parts, primary and secondary. A step up transformer increase voltage by adding more turns on the secondary coil than the primary coil. So if we want to make the transformer to be in a step up mode, we must adding more turn on the secondary coil. other than primary coil. So vice versa to make the transformer to be in decreased voltage. So to isolate transformer that have ratio 1:1 between the primary and secondary winding are often used to protect secondary circuit and individually from electrical shock between energized conduct and earth's ground. So for the next section is about to assemble the component with the connection from the transformer to the capacitor for the measurement. The capacitor of measurement, also known as voltage divider, that consists of two capacitors. So as we use our capacitor divider, so we use two capacitor. So what are we describing on the feature of each capacitor is, in this system they have three type of capacitor is given, which is measuring capacitor that can be used as HV unit for AC voltage divider. We have load capacitor that can be used for impulse divider and load capacitance, and to smoothing and energy storage capacitor, which is the basic knowledge about the capacitor, which is store energy for generation for impulse voltage, or as smoothing capacitor for DC generation. So for the next session will be passed to Asyraf Razak to continue our discussion for today.
Hello, Assalamualaikum. My name is Asyraf. I will continue for the 3 Roman question. In the 3 Roman question, they have instruct me to do the inside its enclosure chassis consists the circuit board with the simple component of small capacitor and varistor, while at both end of the enclosure consists of two termination of female banana connector. We will see at the figure 1 and figure 2. This is the basic of the secondary capacitor. The connection between the banana female to the BNC female, they is attached to the JND grounding to support the system. And the question 4 Roman, there is 4 Roman A, there is need to realizing your knowledge on electric circuit 1 and 2 during the first year of your study, and also refer to the video. Draw a proper diagram to show it. In the question A, the capacitance divider for the measurement by considering high voltage level to a lower voltage level. We will see in the calculation result, capacitive divider explanation. They have two capacitor that use. First is high voltage level, and second the low voltage level, which is 100 picofarad, and second is 2 microfarad. The impedance that we calculate that involve x equal to 1 over 2 pi fc equal to 1 over 2 pi 50, times 50 times 100 pico equal to 31.83 mega ohm, and the second impedance equal to 1 over 2 pi times 50 times 2 microfarad equal to 1.59 kilo ohm. Then we total up the impedance total as xc1 plus xc2 equal to 31.83 mega ohm, and we need to find the current flow in the system. We use the V equal to I times xc total, which is the I value is 3.14 milliampere. Then they have two different voltage for the high voltage level and low voltage level. which is the VC1 equal to 99.95 kilovolt and VC2 equal to 4.99 volt, which is we has shown the result for the two different value. This is the system that we need to describe. Firstly, the first TMB supply is generated to the FC and go through the transformer, and the transformer which connect to the capacitive load at the secondary unit AC, which is that uses the coaxial cable to the FC between the FC and the capacitive load. And this is the circuit for the circuit that we have set up in the PSpice. You get it, SYAZANI?
Yes, yes.
Yeah, yes. We have series the two value of capacitor, which is 100 picofarad and 2 microfarad. The next question is the schematic structure of the secondary capacitor by considering enclosure termination point at both ends and the schematic circuit diagram of circuit board. For the schematic circuit board diagram, please use a proper software to draw the schematic. We will use the six component of the capacitor that we series at the circuit, which is 100 picofarad, 2 microfarad, 100 picofarad, 2 microfarad, 100 picofarad, and 2 microfarad. Next, I will pass to the next presenter, AZZAM.
Thank you, Asyraf. So for the section 3, the question is asked to fix the coaxial cable and tight all grounding termination by considering branded copper cable to the floor pedestal and cases of secondary part for AC, BNC to banana adapter, for secondary for AC and grounding switch. Also considering neatness and clean. In the video has demonstrated some explanation of the connection between the two capacitor of divider using coaxial cable, and the other end of the secondary capacitor is connected to the terminal point of FC. So the question is complete the puzzle in the diagram and then complete your drawing and double check the connection of branded cable at the transformer, structure of divider circuit, and grounding switch. And then the last question is the suggest how to ensure the neatness and clean testing layout. So as you can see, we need to solve the puzzle that our lecturer asked. So you can see the drawing below. From the drawing below is from TNB. Go to the frequency converter, and then go through the transformer, and then go through the first capacitor, which is the capacitor divider, and then the capacitor series with the secondary unit capacitor. So all these things, all these components are connected with the branded cable copper. So the branded copper connected to the building earthing. This is from the video. The branded copper connected to the building at the lab. So the last question is suggest how to ensure the neatness and clean testing layout. Conceal the cable like the branded copper for grounding shown in the video. This is because to avoid incident during the lab session. Second is the place for the transformer and the floor pedestal need to be fixed and permanent. So it will not move by student. So this is for safety, and this one is for safety because once the component is worn, so it will be damage the system. So the as you can see the video, our lab is quite mess because the cable is not properly arranged. So we need to arrange and make it neat and clean. That's all. Thank you.
Thank you.
So thank you for our members, which are Asyraf and AZZAM, for the explanation. So that's all for our presentation for today. So hopefully you can take any knowledge that valuable from us and make as reference. So thank you for again, and Assalamualaikum.
Assalamualaikum.